Welcome back. So what have we done so far? We looked at the measurements from length and distance and also mass and weight. Now we are going to look at some volume measurements. So, metric to imperial. If we look at the metric side, we can see there is litre and milliliter, and then on the imperial side, gallons, pints, and fluid ounce. And that is also why milliliters was then there for a second time, because now we convert that to pints and also to fluid ounce. When we look at the conversion factors, we'll see that 1 gallon is 3,8 liters, 1 pint is 473 milliliters, and then 1 fluid ounce is 29,6 milliliters. And again, this is what we will be using. You don't need to know it off by heart. You can always find it somewhere. If we look at an example, Susan travels to the USA. At a garage, she filled up her car. If she received 10.52 gallons, what is the capacity of her tank in liters? So now, let's go and look at our table again. What do we need to know here? We are going to work with the 1 gallon is 3,8 liters. So it's 1 gallon. Oh, see, I missed. I'm supposed to be a doctor. Sorry for this, guys. Okay, 1 gallon is 3,8 liters, meaning I'm going to take that, what she's got, the 10,52, and multiply it by 3,8, and then your answer will be 39,98 liters. So her capacity of her tank is then 40 liters. Remember, it's always a whole number. So let's look at another example. If Peter ordered 2 pints of milk, how many milliliters of milk will he receive? So what are we working with? We are working with milliliters and we are working with pints. What is the conversion? 1 pint is 473 milliliters, meaning the pints will become more. So therefore we're going to say he orders 2 times the conversion factor, 473. Punch that into your calculator. Remember to switch it on first. And then you'll see, you'll arrive at the answer of 946 milliliters of milk. And that brings us to the end of volume. Let's quickly look at temperature. So in the imperial system, the unit to measure temperature is degrees Fahrenheit. And in the metric system, it is degrees Celsius. Now there's a specific formula that you need to use when you convert between the two, vice versa. They are then going to be the degrees Celsius one. If you want degrees Celsius, it's going to be degrees Fahrenheit minus 32 divided by 1.8. Now remember, both must first do the bracket, right? And then the division. And then for the degrees Fahrenheit, 9/5 multiplied by the degrees Celsius plus 32. So this is just, you choose the correct formula and you substitute whatever you have. Okay, let's look at another example. The boiling point of water is 100 degrees Celsius. Rewrite the boiling point of water in degrees Fahrenheit. So first of all, we need to choose the correct formula. Here it is. Degrees Fahrenheit is 9/5 multiplied by the degrees Celsius plus 32. Now remember BODMAS here. What's going to happen is we are going to substitute first, then we are going to multiply by the 9/5, and only after that we will add the 32. Let's have a look. So the degrees Celsius is not yet there. We are going to take the 100 and we are going to substitute, and then it's going to be 9/5 times 100. Get your answer, add 32, and then you will arrive at the answer of 212 degrees Fahrenheit. In a certain town in South Africa, the maximum temperature was 30 degrees Fahrenheit. Identify the season in which the observation was made. Now, 30 degrees Fahrenheit sounds kind of cold. Let's quickly look. So, the first thing we do is we choose the correct formula. Degrees Celsius is then the 30 minus 32. There we can see we're going into a negative, divided by 1,8. So what are we going to do first? First we're going to say 30 minus 32, which is negative 2, divided by 1,8, and that is then minus 1,11 degrees Celsius. So it will definitely be winter because it's negative 1,11 degrees Celsius. And that brings us to the end of today's lesson. Thank you for tuning in, and I hope to see you again. Goodbye.